Let's take a look at this problem. We want to solve the inequality analytically, support the answer graphically, and give exact values for the endpoints. Okay, we got x squared plus 5x is less than or equal to negative 6. Okay, well, let's talk about this first on the graphing calculator. Okay, this is polynomial inequalities. Step 1, get everything on the left side, 0 on the right side. Step 2, set the left side equal to 0 and solve. And these are your critical values. Step 3, using the x-axis, the critical values, and the graph, then find the answer. Now we have for our answer, we're going to need if it's a less than or less than or equal to, then your answer is where the graph is below the x-axis. If it's greater than or equal to, your answer is where the graph is above the x-axis. And then, if we got less than or greater than, we're going to use parentheses. If we got less than or equal to or greater than or equal to, we use brackets. And doesn't really all fit on the page, but that's okay. So let's go through our steps. Step 1. Get everything on the left side, 0 on the right side. So we're going to take negative 6 and move it over. You move anything across your inequality symbol, the sign changes. So we got x squared plus 5x plus 6 is less than or equal to 0. Step 2. Set the left side equal to 0 and solve. So we got x squared plus 5x plus 6 equal to 0. And this factors using the PSD. PSD because we have x squared, x, no x, and there's no number in front of our x squared. Remember the PSD, we take our number at the end, the 6, and we create our 3 columns. P column, S column, D column. P stands for product. We list all products, give us 6. We got 1 times 6, 2 times 3. The S column, S for sum. 1 plus 6 is 7, 2 plus 3 is 5. The D column, D for difference. 6 minus 1 is 5, 3 minus 2 is 1. Now we're looking for the number in a middle term, but we have 2 5s. Since our last term is positive, that means the signs have to be the same. So this is the 5 we want. So we use 2 and 3. So we got x2, x3. The larger number in the P column you're using, we're using 2 and 3, so our larger one's a 3, will always be the same sign as the middle term, which in this problem is a positive. Number I circled in the S column, S for same sign, so if this one's positive, then the other one has to be positive. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x plus 2 equal to 0, and x plus 3 is equal to 0. And solve those, and I get x equals negative 2, and x is equal to negative 3. Step 3. Using the x-axis, our critical values, here's negative, let's try to get that right, negative 3 is over here, and negative 2 is over here. These split them up into intervals. Clear over here is negative infinity, clear over here is positive infinity. So this first interval is from negative infinity to negative 3, the second one is from negative 3 to negative 2, and this far right one is from negative 2 to positive infinity. Now it says using the x-axis, critical values, and the graph. Now we want a graph at a point where we have 0 by itself on the right side. So I want to plug in this right here into the calculator and see what it looks like. So go to y equals, and I got something on y2, so I'm going to clear that out. Anyway, clear out y1, and then we got x squared, so I do my x key squared plus 5x plus 6, and then graph. Can't see it real well, but since I know what the critical values represent, I know my graph looks more or less like this right here. Doesn't have to be perfect. For this problem, we got less than or equal to. Less than or equal to says your answer is where the graph is below the x-axis. Well, it's below the x-axis right here. This horizontal line here is the x-axis. So this is going from negative 3 to negative 2, and less than or equal to tells us to use brackets. So we put a bracket around each one of those, and that's our answer. Okay, now if I was doing this by hand, completely by hand, well then you still find your critical values just like before, do everything down to step 3. How step 3 changes is we got negative 3 here, we got negative 2 here. These split them up into intervals just like before. That hasn't changed. Clear over here is negative infinity, and clear over here is positive infinity. What we want to pick is we want to pick test cases in each interval. So we want to pick a value between negative infinity and negative 3, like negative 4. We want to choose a value between negative 3 and negative 2, like negative 2.5. And then we want to choose a value greater than negative 2, like 0. Now we want to plug these back into our original inequality and see whether it's true or false. So if I were to put negative 4 back in right here, didn't leave enough room, but we got negative 4 squared plus 5 times negative 4 is less than or equal to negative 6. And this is a question mark. We're wondering if it's less than negative 6. Negative 4 squared is 16. 5 times negative 4 is negative 20. Is less than or equal to negative 6. So we get negative 4 is less than or equal to negative 6. That's false. Negative 4 is not less than. So this is not part of our answer. Now the 2.5 or negative 2.5 here. So I put in negative 2.5 squared plus 5 times negative 2.5, and we're wondering if that's less than or equal to negative 6. Not very good with decimals, so let me plug that in my calculator. So do second mode, do a beginning parentheses, then negative 2.5 close parentheses squared plus 5 beginning parentheses negative 2.5 closing parentheses, and we get negative 6.6, negative 6.25. And the question is whether that's less than or equal to negative 6. And even though it looks like it's larger, remember as the numbers go to the left, they become what appear to be larger, but they're actually smaller. So this is less than. So this is true. And then we plug in this last test case here. We put 0 in for the x into our original inequality. So I got 0 squared plus 5 times 0, and we're wondering if that's less than or equal to negative 6. 0 squared 0, 5 times 0, 0, 0 plus 0, 0. So the question is 0 less than or equal to negative 6? No, this is false. So the only place where it's true is between negative 3 and negative 2. And just like before, these are brackets based upon the less than or equal to up here, where you have a line underneath. So that'd be your answer. That's how you do it on the calculator and completely by hand.